Okay, so we're going to go through the paper from earlier today. Let's start with this one. 4 to the power 3 over 2. The key thing is that the number on top is the index, the number on the bottom is the root. So you start with the roots. The 2th root, the square root of 4 is 2. So this is the same as 2 to the power 3, which is 8. Root 8 in the form m root 2. So you're splitting 8 up into two numbers that multiply to make 8. So we say 8 equals 4 times 2. And multiplication for surds works the same way. So that means that root 8 is root 4 times root 2. And of course root 4 is the whole number 2. So this becomes 2 root 2. Same with 50. You're splitting it up into two numbers, one of which is 2. So we say 50 is 25 times 2. Oops. Which means that root 50 is root 25 times root 2. And root 25, of course, is 5. So this is 5 root 2. Moving on to this. This is called rationalizing a denominator. When the denominator is a surd, it's bad. So the way to turn a surd into a not surd is to multiply it by itself. So we're going to multiply the top by root 2 and the bottom by root 2 as well. If you multiply by the bottom by root 2 times itself becomes 2. And for the top we're doing root 2 times 1 plus root 2. Root 2 times 1 is obviously root 2. And root 2 times root 2, as we said before, is 2. So we get root 2 plus 2 over 2. Do the 2's cancel? Well, no, because of the plus. Can't cancel the sum. Same deal again here. Rationalizing 1 over root 7, you multiply the top and the bottom by root 7. And we get root 7. 1 times root 7 is root 7 over 7. Expand and simplify. Hopefully people were okay with this. You get root 3 plus root 15 times root 3 plus root 15. And then if we do root 3 times root 3, that's 3. And root 15 times root 15, that's 15. So the whole number part of this is 18. But then we've got root 3 times root 15 and root 3 times root 15. So it's root 3 times root 15 and root 3 times root 15. And root 3 times root 15, we already know, works in the same way as normal numbers. So we get 3 times 15 is 45. So this is root 45 and root 45. When you add surds, it's not the case that root 45 plus root 45 is root 90. You add surds like they were x's. So this is x plus x, so this is 2x. So 18 plus 2 root 45. We're not quite done. We need it to be in the form m root 5. We've got the n, that's 18, the number by itself. We need this to be n root 5. And for that we need to split root 45 up. Root 45 is the same as 9 times 5. Root 9 times root 5. And root 9 is 3. So if you have two lots of 3 root 5, that's 6 root 5. So that's what this number is squared. It squares to 18 plus 6 root 5. And so when you've got a Pythagoras question, you're saying that the two sides next to the right angle, when you square them and add them, are equal to the side opposite. When you square k, that becomes k squared. And when you square root 3 plus root 5, you get 3 plus root 5 times 3 plus root 5. 3 times 3 is, 3 times 3 is 9. And root 5 times root 5 is 5, so that adds to make 14. And then you've got 3 root 5 plus another 3 root 5. And 3 root 5 plus 3 root 5 makes 6 root 5. So now you're saying k squared plus 14 plus 6 root 5 equals 18 plus 6 root 5. That's your equation. So if we apply Pythagoras' rule, then the two sides that you can square and add make k squared plus 14 plus 6 root 5. And that adds to make the other side squared, which we worked out from the previous part of the question, is 18 plus 6 root 5. And now it's going to be quite easy to simplify. The 6 root 5s are on both sides, so you can subtract them. And we can also subtract 14 from both sides, and what we're left with is k squared equals 4. Oops, I've just written k squared equals k squared equals 4. So that means that k is either 2 or minus 2, except that of course k is a length, so k can't be negative, so we can ignore the minus 2, and our solution is that k equals 2. When you cube something in brackets, you are multiplying it by itself 3 times. So if we're writing this out in full, this is 3x squared y4 times 3x squared y4 times 3x squared y4. Now you can multiply 3 by 3 by 3, and x squared by x squared by x squared, and y4 by y4 by y4, and that would give you your answer. A quicker way is just to look at all the elements in here. There's no plus or minus, so it's not going to get complicated. We just cube 3, cube x squared, cube y4. So 3 cubed is 27. X squared to the power 3, some people say is x to the 5. That's different. That's x squared times x to the 3, which is when you add them. If you're doing x squared to the power 3, that's when you multiply them, so you get x to the 6. So this is x to the 6. And similarly, if we multiply those two numbers, y4, 3, we get y12. So you multiply, when it goes to the power 4 to the 3, x to the 2 to the 3, you multiply the 2 by 3 and the 4 by 3, which is how you end up with x to the 6 and y to the 12. Expand and simplify. I'm hoping this is fairly straightforward. Bear in mind that 2x times 3x is 6x squared. That might catch people out. 2x times minus 2 is minus 4x. 3x times 5 is 15x. And 5 times minus 2 is minus 10. So you get 6x squared plus 11x plus 10, but you already knew that. Right. To simplify, you've got to factorize. So you're multiplying to make 6 and adding to make 5. That's 3 and 2. Is the bottom difference of two squares? No. Difference of two squares is something squared minus something squared. This is simple factorizing, the kind you did before you got onto quadratics, because both terms have an x in it. So you can take out that x, and it's x times x plus 2. The x plus 2's cancel, and you're left with x plus 3 over x, which cancels to, no it doesn't, you can't cancel those x's because there's a plus in the way, so that's the final answer.